Doesn't sound very loud.
It's okay.
Oh, sorry.
Yeah.
No, me.
Weird. That one should be
Come on. Testing 1, 2.
Here, try plugging. Wait. Oh, somebody took it.
I saw it here like months ago.
Hey, did someone walk away with the 1/4 to 8 cable that was plugged in here? Because now it's not plugged in here.
It's sitting right there. It should be sitting right there.
No, the quarter to 8. It was plugged into this like 2 minutes ago.
And I actually saw it right here a few minutes ago. Did it fall down?
It was plugged into the mixer.
I can't find it. Yes, I unplugged it.
Anyway, right. We need it.
No, there should be a mono. Okay.
This will work.
Okay.
For us, I guess.
Sure.
Yeah, this is how it's plugged in.
Cool. Here, let's unplug that in for a second.
Oh, yeah. Perhaps it is.
Well, then let's just not use the mic. The mic has been hacked. Test. Oh, that's good. Let's use that one.
Test.
Maybe it's just a little busted here.
Yeah.
Test.
Oh, it was off.
Oh,
That was my other thing.
Test. You can use either.
yes. I want
This is James. We'll introduce the space.
Hi.
Hi.
Hey, so welcome to Noisebridge, and we're a 501c3 non-profit tech educational space here in the Mission, and anyone's welcome to come here during our normal business hours, which just means someone's here to let you in. Or you can get RFID access if you want. You can make a donation of a couple bucks, or if you have a bus card, you can scan your bus card over there. Someone can give you access. You can let yourself in between like 10 and 10 every day. And you can just come in, use the space. We're entirely run by donations, and that's optional. It's up to you. So for example, for being here today, using the space, using any equipment that you want for your project that's available, we just ask that if you are able, that you donate. And you can donate online. You can go to noisebridge.net/donate, or there's a donation bin right there. There's a donation jar right at the door. You're welcome to drop cash in it if you want. But that's how we're funded. We're totally self-funded. We don't take money from anywhere else unless it's an anonymous donation. So, cool stuff. And everything in the space is basically available for your use unless it's specifically stated otherwise. So we have a Dead Tree library, and there's a database online. You can locate every book, use it. There is a parts database, parts.noisebridge.net, for all our electrical components. You can use that to find the electrical components over there if you need them for your audio project. We also have this room. This is the Hackatorium. This is our main room. We have the touring room where there will be a children's electronic class starting up in a couple hours. So if anybody comes in for that, you can just point them that way. And then we have church in the back. And there's the 3 different rooms. Classes are taught here. Anytime anyone wants to, you just look to see if there's any kind of conflict. And if there's not, you should be able to have your event as long as it follows our guiding principle of being excellent. And that just means you're excellent to yourself, to others, and from there you can do what you want. So we have wood shop, we have a hot shop that's being built, we have a laser cutter. It's like a 140-watt laser that's being shipped from China to here. It's like 1,000 pounds. It's going to be in that room. It'll be a huge, huge boost for the space. It has a gigantic bed. I think it's like a 4-something foot bed or more. It's huge. So you'll be able to cut all kinds of stuff. We're actively fundraising to help pay for that because getting it here is costly. We have a bunch of other projects happening as well that you can donate to. If you go to noisebridge.net/donate, look it up. We have all kinds of equipment that's available to use. We have 3D printers here. We have a vinyl cutter. You can cut stickers and things like that. We have the flash and Taschen LED projects you can interact with. All of the information's online. If you look at the projects, there's QR codes and links. You can go on our site, look up these projects, and use them, interact with them. You can teach classes here. You can use the AV equipment. You just have to be respectful. And there's also free parts in the back, hack shelves. You can use those parts for projects. And yeah, there's 2 bathrooms in the back. And welcome to the space. And we're very thankful that we're able to host Peter.
Thank you. Okay, so right here, what's your name? Michael asked me, is your site a Rainbow Random site a long time ago? And I thought I would start with that because, yes, it was. Originally, my site was Rainbow Random. And then my friend made fun of it a lot because it sounded like reading Rainbow, which I liked, but he, I guess, exposed a weakness in me, or the idea. So then it became Siat Lombard, which held most of the esoteric analog instruments that I design and sell. Some of them are free. The free ones are paper circuits. So here's the current list, of the stock list, and it's changed a lot over the years. I've always been inspired by Don Buchla, the Buchla website. Before, a while ago, it had multiple layers of different web designers had done it, and they just kept the layers. So you would push home, and it would go to a different home, and there would be a circle of different homes. And I love that, and that's good about just synthesizers in general. So there are different homes hidden. I kind of compressed it. I do what's called mulching. On the West Coast, they call it bark chips. Or in Portland, they call it bark chips, but we call it mulch on the East Coast. My dad taught me that word. He called it mulch. And that's when you just grind up wood and make mulch. You know what mulch is, for around trees. And so here's the mulch that I have at the bottom, the unsellable mulch. Actually, the paper circuits is the first link there, so I would actually go to that and just explain what a paper circuit is. A paper circuit is a prototype or just an idea or a free design that can be made on paper. The reason I say it's a prototype, there's multiple purposes. Usually I start out prototyping a design with it, and maybe I go on producing that design, or maybe I don't go on and produce that design, and it stays a really kind of esoteric idea that's only had on paper. So Mr. Grassy is actually one of those things that is still just on paper, but actually I have the boards going through the factory right now to make that, and it's going to be a Eurorec module. I'll talk about the Interroga joke later, but I'll just show you what a paper circuit is. Paper circuit is, you probably, maybe you've seen this. This is a paper circuit. This is the newer, old Mr. Grassy. And so you print out this paper, you fold it in half down the middle there, and then you pierce these holes. Oh, you fold it in half and you put a piece of cardboard in, you glue the cardboard in, nice and neat. You like squeegee the glue so it makes a nice neat layer of paste. And then you fold it in half, and then when it dries, you pierce all these holes with a needle, and then you insert chips, resistors, transistors, capacitors, and on the obverse side, it shows you how to wire them, and it comes out looking something like, let's see if I can find it actually. It sounds like that. These are just paper circuits that people have made over time. I guess there, if you could see over there, that's the back side of a paper circuit, probably with lead on it. And here's actually an old Mr. Grassy. I have a few of these sitting around home, and this is I think you can play songs with it too, and I wish I spent more time playing songs, but Kiri here helps me out with this. Nick. Oh, from now on he will interrupt me. Oh no, you're not going to play? Okay. Say hi.
Hi, Gary.
Thanks for being here, Kiri. I love this guy. The 2-year-old's at home. So, paper circuits, lowest tier. There's some dark corners here. We talked about, someone was talking about the drum machine as the plum butter. And that's a production instrument. Here, it's a drum machine. Right side is the deer horn. It's a gesture, it has an antenna on it, and it takes gestures kind of like a theremin, but a little bit different. The idea behind the deer horn is that Clara Rockmore asked Lev Theremin, can I have multiple theremins, multiple antennas with different notes? And he said, no, you only have 2 hands. One is for volume and one is for pitch. And I just thought that question was too quickly answered. So the antenna here takes your gesture as a theremin would, and it outputs a CV that's based on a distance, and that can be fed back in to change the pitch of the instrument, like a theremin. It also derives an envelope based on the acceleration or the velocity of your movement, and creates a nice envelope from that. So when I move my hand, it'll get louder too. So, but it'll die away when I hold still. So I can play notes on one of these, but I can have a bunch of them, and I can have an organ of theremins with them. And so that branches off as its own instrument, a deer horn organ. But it's included in the plum butter drum machine because it's a drum and drama machine. So the drama is the non-drum things, like theremin tones that waft gracefully. But the drum machine has a longer story. And it started with the Rolls 5 paper circuit synthesizer, which is down here in the mulch. And this is a Rolls 5 hanging synthesizer, and it's based off of these geometries, and those are pulse rolls. So I was in the Baltimore Public Library and looking at a book by Delton T. Horn called Oscillators. And one page details a oscillator called exotic oscillator, creates unpredictable tones. And it's basically the bistable multivibrator that is in the bistab. Or it's actually an astable multivibrator, but I like the word bistab better than astab. And basically it's made up of a neuron, and I would usually do this on a chalkboard or a whiteboard, but it's okay, we're just gonna breeze through it. A neuron is made up of a capacitor. This is a hairy capacitor. It's unspecified what value it could be. And the capacitor comes from the collector, or the output of a transistor, and it decouples it, and makes a pulse into the input of the next transistor. And so basically, a neuron is like a spike that fires into the next neuron, and it creates a time delay too. And that's all we need to say, because we're just going to breeze to the next level and say that there's even rolls of neurons and there's odd rolls. And Delton T. Horn talked about the odd roll in his exotic oscillator. He said it's unpredictable, we don't know how it works. And so I investigated that more on my quest for a free jazz drum machine. And I found that my explanation for that is that an even roll makes a stable sequence of on and off, represented by filled lozenges and empty lozenges. And they always accentuate each other in the rhythm that it makes. So if it's, depending on the capacitor, it'll make a rhythm like or so on. If you have bigger capacitors, it'll go slower, etc. But an odd roll is not self-accentuating. So if you start here, it goes on white or black or white or black or whatever you want to call it, and it never ends up on the same thing. So it doesn't know where it is. And the result is that an odd oscillator, in most circumstances, is running at a paradox loop, which means it's trying to resolve this paradox, and it's running at the highest frequency it can go, which usually is ultrasound, and it's at an unpredictable, unknown frequency. So what happens is if you mix these, I went further and said, I'm going to mix odd and even. So here's a square, which is even, with a triangle odd, even, odd, and make an assemblage of them. Through resistors are just connected directly, and what happens is, ideally, a free jazz drum machine, which is a mixture of pulses, steady pulses, and bursts of ultrasound, snares, or a ride cymbal, or whatever you want to call it. And the bursts of ultrasound, furthermore, often have an unknown frequency or a chaotic frequency, so they come out as noise. So we get the timing clock for the drum machine is not just a simple do, 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 do. It is an assemblage of bursts of noise and limping rhythms, and the best ones are the rhythm changes over time. You can get it like that if you're really good at wiring it up. And then to manifest these, I said, well, we need some manifestors. And there's 3 manifestors: gong, ultrasound, and AV dog. The ultrasound takes the ultrasound that is present in this burst of noise and converts it to an audible frequency, although it's probably already audible. And actually, I'm going to try to just see if I can play off the web. Oh, that was a small play. And if I mouse over, I might be able to... Oh, good. So that was easy. So I'm going to try to play an ultrasound module. It takes one of these assemblages as its input, and so you can hear. This is a simple clock. I guess I just used a simple one for the. Well, there's some bursts. So it just takes the pulses and the bursts of sound and converts them into an audible frequency. Not unlike what used to be called clicks and cuts music, right? Or some stuff from the, I guess, IDM or the early 2000s. They were interested in the junction between the hard edge between samples, where you have just pulses and cuts. So I was inspired sonically by that to bring that out. And I think it's effective as a part of the rhythm that's more abstract. And then, so an easier thing to understand is the gong. So the gong takes all these pulses and boils it down into longer time frames so it can make these more recognizable drum machine beats out of it. And there's all kinds of modulations that I'm not talking about. Right, so it's resonant filters being plucked by pulses that are held over time. And then the final is the obverse of the gong is using a resonant filter at the low frequency. So you're resonating the pulse itself. You're getting undulations from the pulses, and then converting that into an audible product by amplitude modulating a triangle wave. So this is the pulses going through a low frequency resonant filter. So it's like a buoy on the water being struck by driftwood. making it bob. So the mixture of all these manifestors, I'll try to play some tracks. Oh, here's the deer horn. Again, that's a drama sound and not a drum sound. Oh, I added a snare drum to it. Snare drum. And then let me just play a sound, a mixture of them all. And I'm not the one who speaks for Plum Butter in the end. I mean, this is an instrument a product. And so you can listen to Plum Butter by other people. But I just wanted to show how this complicated product came out of a drum machine that came out of just a simple esoteric oscillator idea. And so I'll just detail real quick the general outline of SynthMall, which is I created this umbrella company because C.L. Lombard came from a mushroom drawing that I did in 2000 in Chicago that is called Stores at the Mall. And it's down, I think, in rooms. It's the manifesto. Oh, it's the coloring book. No, is it the coloring book? Yeah, it's the coloring book. Okay, at the mall, I asked Olaf Malbenthie, Siat Lombard, Faberé, Twainer, Knobsrime, Big Mill, Trenu, Shabobo. Actually, Big Mill is owned by some new web company now, but I still own it here. Tocante, Docalls. And so this, I brought this drawing back from my notebook and said, I'm going to use this. I'm not going to make up any more new names because they're right here. So Siat Lombard was actually very early on, was the original company. Shabobo makes the synth, and that is a digital manifestation of everything that I've been working on here, propelled by squish bars, which is something I've been working on. Not going to talk about that too much because people are making it. And Tocante, you know what is going on because you're making that too. Tocante has 7 pieces. The triangle, square, and circle are the triangle wave, square wave, the sine wave. And then the Carper, can I play the Carper? I'll just play that into the speakers here. The Carper is the Carplus strong. By the way, people that have Carpers, it'll go off when you let go of it, and on when you touch it, just like all of them, to save battery. But if you plug this in, it'll just stay on. If you plug it in with a 12-volt adapter, it'll just stay on, like kind of like a studio instrument. It has, like with the best microcontroller circuits, it has bends for all kinds of circuit bends, just like they all do. So the idea was I had made these, the 3 original ones using the capacitor series, and that makes the scale. Let's just go through the scale. And that is based off of the capacitor series 10, 15, 22, 33, 47, 68, and 100 again. And within that decade, I can actually create more by doubling our halving capacitors. Either the former is by parallel capacitance, and the latter is by series capacitance. So I can take 10 and make it into 20 by putting them in parallel. So I can have 20 versus 22, which is already there. So I have even more things I can generate, because these capacitors are not the same over the octave. They're the same over the decade. So a decade is 3 octaves and a major third. So this scale is completely outside our octave thinking of music. It's a decade thinking of music. And I can create, so let me just go on. 68 divided by 2 is 34 versus 33, which is just a single, and that creates this nice microtone. That's 34 versus 33. So that's a just intonation instrument. And I could take that just idea and take it out of the hackerspace that it was in analog, and I hacked it into the digital space here. It's kind of, I was cheating a little bit, but this is the interrogative. You interrogate what's there and make it into sound. So what was there was this capacitor series that no one ever really listened to, but actually I think people were listening to it, because people make their oscillators and they put a 10er in, or they put a 22er in, and people were always hearing it. I just wanted to formalize the hearing of this series. And in the Carplus-Strong algorithm that the Carper is, it's a string emulation, a digital string emulation. The simplest thing, using delay lines. You just make the delay lines of that length, 10 or 22 or 33. It's just converting these capacitors into code, and it's seamless once done. So it's cheating, but it's part of the series. This is using the same recipe as before. And one more thing that happened was Zener was putting white noise into resonant filters, and I think that's around somewhere there too. So that's like the spaceship, on 2001, the sounds of the spaceship, like by the wind through the pines. So you know what Tocante is. If there's any more questions, we'll cover that in a second. So Tocante was a coolifier of iASCII F Mobenthie, which is, after many years of not doing Eurorack, my stuff is not usually Eurorack, it's 9-volt standalone stuff. I said, well, why not use Eurorack as a medium too? So I created these modules, and they're based on, there's a manifesto in here, but the main part of the manifesto is, okay, well here it is. iASCII sees analog synths as obsolete, and this is the source of their potential. iASCII does not care about extending them, but to bring about their downfall with his masthead, the paradox wave. And the paradox wave, I spoke about it a little bit in the role synthesizer, where something can't, a circuit cannot resolve a paradox that you've put it in. And the main way to do that in these is probably in the DNUM. It has a bounds and bounce controller. It's an oscillator, but it has 2 FM inputs, shall we say. And bounce is the typical one where you think of the speed of the waveform, how steep its slope is. A steeper slope makes a faster frequency. But the bounds is usually not modulated on oscillators, and that's how far does the oscillator swing. So if it's smaller, it actually gets faster and faster because it's trying to swing within the smaller space. With the same steepness of slope, it gets faster and faster. It also gets quieter. And also, FM modulation is different when you're modulating bounds. And when you bring bounds all the way in, it doesn't know what to do. It just goes up theoretically into infinite frequency, and then at that point you're hearing all the artifacts and problems of the chips and transistors themselves.
Peter, one question.
Okay.
Is there any concept of 1 volt per octave across this?
No.
Didn't think so.
Yeah. Well, it has, everything has attenuverters on input, which I personally think is more important than 1 volt per octave. But also, this one has 2 inputs, so there's no way to lock it to the octave. Also, something like forces, these are also bounce. There are 4 oscillators that bounce off of each other. So again, if I could do this on the whiteboard, which is okay, we don't. Think of oscillators bouncing, 4 bouncy balls in a perspex tube, and you shake the tube up, and the bouncy balls are bouncing off of each other, and none of them makes a stable frequency because they're all bouncing off each other. So this is intentionally doesn't have frequencies. Well, it has spectral. And there's a few other. One is something I've been playing with for a long time, which is a J.C. Sprott's chaotic resonators. This is according to a differential equation, a 3rd order differential equation. The standard state variable filter that we hear on, and pretty much all filters are 2nd order. They're based on the wave equation that equates acceleration to position, and the velocity is a Q factor. But when you add another one, it's called jerk, the acceleration of the acceleration, or the velocity, the differential of the acceleration. So, right, I'm accelerating, but how am I, like in my car, if it's a nice car, I just accelerate smoothly. But if it's a bad car with knocking in the engine, it goes like, you know, that's the jerk. You take the jerk, you put it through a nonlinearity, you have a chaotic resonator. It's a physics actual pursuit, and it draws a lot of the strange attractors. And so I just tried to make one that, I don't own this. I called it Sprott. It's after J.C. Sprott, a physics professor in Wisconsin. The only thing I did was to add voltage control to everything, which wasn't on the market, so I just targeted that. So, market-wise, that's the market. Marketeering is the IASCO mob and fee. So I wanted to create something that was a counterpoint to the marketeering. Of course, it's all market. Anyway, the idea of Tocante was no knobs, no voltage control, just not the opposite, the farthest opposite I could find of modeling, of Euro.
Since you're talking about this, would you just talk a little bit about the Tocante? Because I know you said one person's building one and how that relates to all this.
Yeah, that's here actually. It's a crossover. So here's a Tocante. It has pretty much like kind of everything you see on all the different Tocantes. It's a control voltage generator. It's a touch controller. So I've been working on the interrogajoke, which is interrogating what is a touch controller. My main problem, or my main interest, is that touch controllers are using capacitive sense, and there's high frequencies coursing through your fingers, that your fingers change the capacitance of that, and it detects a finger. But touch controllers don't actually bring those frequencies are there, but they're not part of your output. So I wanted to listen to those. So this is like the traditional touch controller. All these are oscillators in the Tocante scale, whereas like the straight Tocantes are at 1 nanofarad to 10 nanofarads, 1,000 picofarads to 10,000 picofarads to get that audio violin range. These are at 100 picofarads to 1,000 picofarads, and they're running at anywhere from like 20,000 hertz to 200,000 hertz. So it's definitely stuff that you don't hear. But it makes for a good touch controller. So it generates, through phase lock looping, it generates CV outputs and a gate. And that's the trad part of it. The rest of it is not traditional. These are square wave octave dividers. So it takes those super high frequencies and brings them down to a hearable thing. And that's just a touch output, like the primitive Tocante. Just touch, the signals are going through your finger and out through, I think, this jack up here. And then up here in the middle are heterodynes of the frequencies. So it's kind of like how a theremin works, is crossing, you know, if you cross 100,000 with 100 and 1,000, you get, if you multiply them, you get a 1,000 hertz product. So this is another way of listening to ultrasound. The main way of listening to ultrasound is through heterodyne. And so that's all part of trying to get these frequencies that are used just for touch sensing and use them for musical purposes, like bring them out somehow. And because they're a very high frequency, the circuit bending points right there do a lot to really mangle them. Because the higher frequency stuff is a lot easier to bend because you have a lot of capacitance relative to it. And also, they go through your body capacitively. So signals are everywhere once you start touching these points. So it's trying to circuit bend the idea of the touch controller. And I'm not really gonna, I'll let people touch the Dindat Deuterogram. That's just extremely esoteric, and it's just trying to bring back something old, and it's good. It's an instrument for babies, really. I'll just play one real quick. But Kiri will play it. Maybe we'll play it. Maybe now's not the time. It'll be lunchtime soon. But that's the viral. That's not the one I want. Actually, this is the original instrument for babies. It's inspired by Kiri. Oh, the stereo isn't going out. It's just...
It's a mono cable.
Yeah. And I have a converter, but I'm just gonna do the idea of the instrument for babies was he went up to the stereo at home and did like that to the two knobs, the volume and it was an old stereo, so it had those two big knobs, the volume and the tuning. And it made a cool sound, but I thought there's a lot more in that gesture, just to think about that gesture and use it, just make something that's for that gesture. So I had actually made an instrument a long time ago. One of my first DC's instruments had two big, it was a lot bigger, had two big knobs and a bunch of these nodes. These are just the same circuit bending nodes, but as brass pegs. And that's a really great way to play it because I can weave wire in it. And I'll show that later. And the idea is to process these torque gestures. The higher the knob is, the higher frequency it is, but it samples the, when you change direction, it samples the place you were at. So it creates something you often hear in modular synthesizer performances using random melodies or stepped melodies. So it has this stepped feature, and then it creates an envelope just based on the velocity of your torque. So I want to think of a knob. The point here is to think of a knob not as something to tweak, but as an interface, a playing surface. Just a simple knob, not create a new whole playing surface that's like a weird touch controller, which is cool, but just think of a knob as something to play, not as something to tweak. And again, it's trying to deconstruct what Mob and B is focusing on the Eurorec, which a lot of times you set a frequency or set stuff, knobs to set. But this is just knobs to play. battery right now, so it's a little bit clown town, but I like that. They're a little bit bendy, because to make a really complicated analog instrument with 2 speaker drivers in it running off of 1 battery, it's gonna be bendy. And I did a lot of really cool tricks, I think, to try to unbend it, but this is the best I could get. It's good though. You hear the pitches are a little bit bendy. So, but that. I'm not intending. That is just a weird thing that I've tried to actually make a band instrument. It's not a superstar. It's just what it is. But are there any more questions?
I have a question about that. I forget where I read or saw it, but I thought that you had addressed a series of nodes in the center of that.
Yeah,
change the internal. I'm not gonna. I
That's
just want to
part of it,
ask
too.
what's up with that.
Well, it's when you play it. Well, maybe after lunch, I'll just try to set these up better, experiment with them. People can do that. That's going to be the best way to do it. But these nodes in the center control the internal rewiring of it. So whereas if you wire to these nodes, it's going to be just a general process of circuit bending. This is like a circuit bending recoding. Like if you have on your speak and spell, you take the speaker output and you take it to the language input. You know how speak and spell work, the circuit bending works, where you change the pitch of it and it's like da. But if you get the right spot, you can hit the actual semantic input pin, and it makes it go that kind of thing. German, yeah.
I guess I'm kind of curious if you could talk a little bit more about the deconstruction in like I guess tactile use of the instrument. I'm sure people have different reasons why they're interested in your designs. But like I'm interested in, I guess, as a musician, and then the idea of interacting with this instrument in a different kind of way. Like I see you have like the brass peg version versus like banana jack version, which for people might even be different from what they're used to, right? If they're used to a modular with like a small, different kind of jack cable system, or used to playing maybe just like a traditional instrument, like an accordion or something. You know what I mean? Can you talk about how that you feel that with these instruments?
It's mostly about inputs and outputs. Like I actually thought about doing nodes on the Amalfi on the Eurorec modules, but then realized that, well, first of all, the interface is very tight, and nodes, you can't just squish and weave nodes when it's a really tight thing. But also Eurorec modules are strictly about input and output. And actually I wanted to treat that as part of the medium. And here we go with this sexist critique of analog synthesizers. And, well, I'll just say that these are intended to be androgynous nodes. They're both inputs and outputs, which is the natural state of a node. Any circuit node is going to have something coming into it and something going out of it. And we only think of outputs as outputs because they have a buffer, and an input because it has a buffer too. But if you take that buffer away, you're actually just interacting with a node that has tensions between input and output in it. There's a reason they call an antenna tower is a transceiver, a transmitter and a receiver at the same time. And that, I think that extends to electronics too. And I make sure that all these nodes have a similar impedance, a relationship of the tension between input and output. Like none of them is too much input, none of them is too much output. So they all, when you cross them, you're crossing nodes. You cross these nodes and they interact with each other. It's like taking a piece of lace and folding it on itself to create more patterns out of it. I think this concept of the nodes like that, I haven't had these brass nodes hanging out in a while. And actually someone asked me recently, I think it was you, was I going to bring back the brass nodes? I think someone named Bill asked me that.
I asked you that.
And I thought that was a great question because these are unique and they look good. They look really good. And the way of playing it, I find, is actually really nice compared to banana plugs, which is, again, that, like, these are randomized colors, but still you are making intentional decisions to connect this one to that one. And it makes for a slightly more repeatable thing, but I still think that just randomly using this, kind of like a Brillo pen or this stripped bare wire, just to weave between the nodes. It's a lot more experimental, and it's a lot more rewarding to me. You go into doldrums, but then you just rip it off again. Go ahead.
You can use also those banana plugs that have the contact outside, similar to the
Right.
ones Munchie use.
Yes.
So you can still have touch, or you can have plug.
So yeah, All Electronics sells the cheapest, and so you put all those just studs of bananas in there, and you could recreate this, but
Yeah, I know. But
yeah,
it's a-
that's an extra work step.
Yeah.
Yes.
Well, you're actually talking about the bare banana jams.
A
yeah.
bare banana gel.
Yeah.
Right. Oh,
Which allow is like you have colors. You have it's like a little cylinder, but you get the metal part on top.
yeah.
So you can still touch them, but you can actually then attach them to other things if you want.
I should do that too. That should be a third.
They
Yeah.
work really nice.
They're really nice, yeah.
Some of those right.
Well, let me just finish up with
Yes.
James. Oh, no, not, yeah, right there, yes. I just wanted to see if anyone else wanted to ask what James was asking, or is there any other interest in the interface that we need to talk about? James, did I touch on that, or?
Yeah, a little bit. I guess I just feel like I don't know. It's hard to explain, but like using, for example, like an instrument for me anyway, off of designed off of a breadboard, so the points being just wire connections,
Yeah.
right? Which is a different way of doing the same kind
Well,
of
when
thing.
you're on the breadboard, it's easy to melt it. I think I'm trying to make instruments that don't need an instruction manual, and you can play them intuitively, and you can't break it, too. The very first instrument I made was, well, not the very first, but I got a grant from Foundation Daniel Langlois to make an instrument that's touching, and it's about circuit bending, an instrument for circuit bending, and you can touch it, and it's called Shimp with an I. I like to repurpose names. Here's a Shimp. I do not have an actual, well, I guess the best picture is you can see people playing it here. And actually, I think this is one of these is in San Francisco, somewhere. Anyway, it's just an open circuit board. People put a spoon in the mouth, and the signals go through your fingers, through the spoon, out to the amp. The only thing is, if you have a piece of metal, or if you just use the spoon itself, it's going to start breaking the connections, because some androgynous connections are stronger than others. In fact, some are completely, all 12 volt hard current going into the base of the transistor, and that will pop the transistor. So the process became to curate the nodes and find the truly androgynous ones. And I'll show you the din, dat, and deutero that came out of that process of curation. I don't have any actual straight, well, that's playing it with worms too. But then, so bringing the case back, the importance of wood is to have these nodes penetrated that are the curated nodes, the special, the important, the nodes of import from within the circuit that can't be broken. So again, I'm trying to make it so that it can't be broken, but it's still intuitive. So the case is not to make it less intuitive, it's just to make it more intuitive, more risk-free. So I think that intuition is an answer, one other clue to the answer of your question. So, and the last part would be that something to think about the musicality of it would be you hear a cello player and they're silent. You know, they're not on. You don't just turn them on. So that's why I worked with these bars. This is a bar instrument. This is a Sidraps organ. And these bars, like on the shinth, however we're going to see the shinths, you just press them, or you squish them. And depending on how hard you squish, they get louder or quieter. But they're silent when unsquished. So that's like, there's intuitive patching and then also a way to control the silence. And that's a purely musical concern, but I think everyone can appreciate the silence.
Just want to ask, kind of touching on the wood, these Tocantes, according to your site, it says they were plotted or expired at Plowley, Connecticut. And I just got back from Connecticut. I don't leave town very much, but I was in a 100-acre wood, and, long story, but...
Did you check for deer ticks?
Absolutely. But I was in a part of western Connecticut that my friend who grew up there and was born in the cabin that I was in said it was at one time clear-cutted for making, I guess, tar. I forget what the industry was. So anyway, I get back here and I see your site and they're talking about caves and things, and I'm just like, what prompted that? What were you?
Well, I was in Connecticut,
okay,
getting a master's degree at Wesleyan, and in the last 2 years, well, a year ago I finished a master's degree in music at Wesleyan, and that was in Middletown, Connecticut, and I found out that there was a Civil War, or Revolutionary War lead mine down by the river. It was like malarial waters and this old lead, just a cave, and I just like site-specific. I mean, I've always been thinking about lead. My initials are Peter Blasser, PB, and I think lead is a really interesting problem, and a poetic problem. But think of the pipe organ is a collection of lead pipes encased in wood to sing to the glory of God. And so that, to me, is a really interesting poetic use of lead. You know, it's not for a battery or something. It's a way to sequester. You know, we have carbon sequestration. To sequester lead in an artful object. And you guys are actually, I don't use lead solder, but you guys are using lead solder today. So you're doing your part for lead sequestration. And also, a point would be that these do not use electrolytic capacitors, so they should last forever. Actually, the batteries are going to die. You know, I don't know when they die, but they recharge. They work really well. But anyway, I try to be part of the land. And, well, the wood is, most of the wood here, if you have mulberry on yours or sassafras, that's from Connecticut. So, and the mulberry will go black over time. Well, also, the triangle, square, and circle is based off of Anthony Braxton's improvisational conducting technique, where it's just triangle, squares, and circles. Square is fixed material, like written pieces. Circle is improvisation, and triangle is a synthesis. So, like, triangle would be metachaos, what's it called? Hyperchaos of those other materials. So that was in Connecticut too. Thank you for asking that.
Cornwall, Western, by Kent.
Cornwall, Western, by Kent.
Yeah, it's a very small place.
Yeah.
Do you happen to know whether the Mocante is in production right now?
It is, yeah. I have one here, but I don't have a Eurorec 2.
Are you coming to the meetup tomorrow?
Yeah.
Would you mind bringing that?
Yeah, It's for someone, but we can open the box. Yeah. Yeah.
What's that?
It's here. It's spoken for, but we'll see.
So then do we not bring it back to David today?
You should bring it back to David today.
Well, I can make another. We can figure it out.
I'll ping David.
Yeah.
I'm just really curious to hear it in action.
Okay.
Does it generate sound?
Well, yeah, so that's the thing. Usually touch controllers don't generate sound. Okay, this generates a CV based on the triangle that you touch. It's a monophonic touch controller. A gate when it locks to your touch. And then furthermore, it generates octave divided square waves that you touch, like on the Tocante Pure instruments. And those are based off of the ultrasound that is used for the touch controller. And then two more things are the hard and soft heterodyne waveforms, and those are also audio that you play. So you can, it's a combination of touch controller outputs. So you can play your monophonic synth on it, but then you also can create related sounds that might be more chaotic, or might be more, the square wave part is like kind of like a pipe organ. It has all those octaves. So it's a mixture of everything. Okay, I think we should, oh, we have 40 more minutes. How about we start cleaning up, make sure everyone's set, and
I want to go home.
we're not going home, we're going to lunch.
It's like home. Sure.
Does that sound good?
Sounds good.
And then when we can come back after lunch, do final cleanup, and I'll put instruments out, and we'll make sure everyone's working. And thank you for making it work.